In this experiment, we are going to study whether all soils absorb the same amount of moisture or not. The material required would be a plastic funnel, filter paper, beaker, soil of different kinds, and a measuring cylinder. Set the filter paper inside the funnel. The funnel could be of plastic or of glass. And after that, put 5 spoons of soil sample in the filter paper. Means you have to put the soil sample inside this funnel through the filter paper. And after that, using a dropper, you have to add water to the soil. So the water should be measured. You should know exactly how much water you are putting in the soil sample. For this, you can use a measuring cylinder, and from there you can take up the water using a dropper so that you know exactly how much water has been used. You have to keep on adding water to the soil till the time the water starts trickling down. So as soon as the water starts trickling down, you can make a note of the volume of water that you have added to the soil sample, and you can repeat the same experiment using different kinds of soil samples.
To check whether all soils absorb the same amount of moisture, let us perform an experiment. Here I am using sand. So as you can see, this is absolutely dry sand and it's in the form of a very fine powder. I have a funnel with me. I take a filter paper and I will fold it in such a way that it fits into the funnel. So I folded it like this. I've given it 2 folds. First I folded it into a half and then into a quarter. And then I will set this up in this funnel. I will fix it here like this. With the help of a spoon, I will add around 100 grams of soil to this funnel. So since I have taken sand here, so I am adding around 5 spoonfuls of sand to the funnel like this. You have to be careful that the soil should be powdered and absolutely dry if you want the perfect answer to your question. I have a measuring cylinder with me in which I have around 100 ml of water. So it is difficult to pour the water directly using this. So I will first pour the water into a beaker. And then drop wise, uniformly, I will add water to this soil till the time the water starts trickling down in the beaker. So we know the initial volume of the water that we had taken was 100 ml, and after the water has been added to the soil, we will check like how much water is left in the measuring cylinder. That will help us find out like how much water was absorbed by the soil. So I am just adding water to the soil drop wise uniformly, and the soil is absorbing almost all of it till now. And you can just observe the moment this water starts trickling down. You have to do it very slowly using a dropper because that will only give you an exact idea, because if you pour it all at one go, you will not be able to find out how much water has been absorbed by the soil, because all of a sudden it will start draining down. It is still absorbing all the water that I am adding to it. So now you have to be careful because the water could start trickling any moment now, because I can see the soil, it's almost wet now. And yes, look at that first drop of water that has dripped in. So I am going to put this water back into the measuring cylinder, and we will see how much water is left in the measuring cylinder. It's around 89 ml. So we started with 100 ml and 89 is left. That means 10 milliliters of water has been absorbed by this soil here. And for calculating the percentage, you can perform the calculations as I'll be explaining next.
Let us now perform the calculations. The weight of the soil sample that we took was 100 grams. The initial volume of water in the measuring cylinder that we took was 100 ml, and the final volume of water in the measuring cylinder after adding it to the soil sample was 89 ml. So I'll take it 90 ml here because around 2 to 3 drops trickled down in the beaker also. So that is why instead of 89 I'll take it as 90 ml. That makes the total volume of water absorbed by the soil as like 100 minus 90, that is 10 ml. And the weight of water absorbed will also be 10 grams because 1 milliliter is equal to 1 gram. Now for calculating the percentage, U minus V, that is 10 divided by 50 into 100. So how much water has been absorbed by the soil? It's going to be around 20%. So this shows that sandy soil does not absorb much water. Only 20% of the water has been absorbed by the soil in this experiment. Similarly, you can try this experiment using different soil samples. You can use clay soil, you can use loamy soil, and then compare the water holding capacity of different types of soils.